Hello, everybody. Hello, ITkonekt. How are you? So good to see you all. Can we focus on something pretty important, near and dear to my heart? We need to get a selfie before we get going, okay? So when I say open source, you all smile, you pretend to be happy, and we take a photo together, okay? Ready, steady, open source. That was just terrible. Just terrible, really. Try again. Ready? Open source. Good stuff. All right, my friends. Well, I am so happy to be here, ITkonekt. This is my first time here, but I've got a lot of friends from here who are like amazing programmers, and they're out there in the world doing amazing things. So I've always wanted to come here and see the local community. You have a really interesting opportunity before you, right? You know that, right? Right now, here in this time, in this world, you are people that are learning how to do software in a time when software is everything. It is the thing that is changing entire democracies. It's changing other parts of the world. It's creating new value, new businesses all around the world. And it's people like you who are doing that drives that change. So it's a really wonderful thing. And it's super nice for me to be here. I'm glad to be here to meet you all. So with that, my friends, I want to encourage you to go out there and do good things with your opportunity. And also, since we're now kind of, I think people in the back are almost sat down, maybe, I want to encourage you to take note of this slide. This is probably the most important slide that I've got for you. This slide contains, there's a step there, big red line. This slide contains arguably the most important thing that you're going to need, which is the Git coordinates where you can find the code for your own reference for later on. That code is what we're going to talk about today. I don't want you to follow along with everything that I'm going to be doing right now. That's not the goal. The goal is to appreciate what is possible, and then since you're all really smart, you'll be able to figure it out later on at your own leisure. If you have questions or comments or feedback, please reach out to me. I'm happy to engage. I'd love to have your input. I'm on Twitter. I'm just curious. How many of you, 2019, how many of you are on Twitter? Twitter. All right, the rest of you, get on it. What are you doing? It's a great place to be. It's where all the developers that drive the open source that power your business are. It's the new IRC. So join me on Twitter. My direct messages are open. You can send me a message, no problem. What about email? Email. Is anybody using email? Email. Anybody? No. Okay, good. I'm not really a big email fan, but, better than Slack, right? So sort of like email, Slack. I'm not really a big fan of Slack. I have a friend, James Ward, who says that while he's not entirely sure, he thinks that based on CPU activity alone, that Slack is mining for Bitcoin. I can believe this. All right, a little bit about me. My name is Josh Long. I work on the Spring team. I'm going to, do you see that? They made a toy. They made a toy out of me in China. That's kind of interesting. I have training videos on Safari. That's a thing. I wrote a book called Cloud Native Java. This book came out last year. 2 years ago, 2017, we finished the book. The book is all about how to build applications that survive and thrive in the cloud. It's about how to build applications that are meant for the cloud. And the book took it's a book on which I worked with my co-author, Kenny Bastani. We worked on this book for a little bit, and we thought we would be finished very quickly, no problem. 6 months, we would be finished. Oh yeah, good stuff. We thought we'd be done with the book very quickly, but it did take, we thought it would be 6 months, no problem, just 6 months. But we thought, no problem, we'd be finished. But it actually took just a little bit longer, just a tiny bit longer than 6 months to finish. Not much longer, just a little bit, just a tiny, just a very, very small, it was like 2 years, okay? It was 2 years to get this crazy book out, okay? And whatever, there's a lot of good reasons for that, though, okay? There was debate, there was discussion, there was deliberation that went on between us, the author team, and our publisher. The debate that took us an extra 2 years was the discussion of the animal on the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't matter what's in the book itself. Nobody cares, right? Nobody's ever even read them. What we cared about was what was the animal on the cover. And we eventually settled on a blue-eared kingfisher. This is the bird, which has blue ears. The bird is indigenous. That is to say, it's native in English. You'd say it's native. It's only found in the Indonesian Java Islands. So it's a bird that is native to the Indonesia Java Islands. And birds fly, yes, through the clouds. Through the clouds. So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. It's okay. Never mind. It'll come. Give it time. I have a podcast, a beautiful podcast. You can download that if you listen to podcasts. I do videos every Wednesday called Spring Tips. There's a playlist there. I've got a new book called Reactive Spring that I'm self-publishing that you can buy on LeanPub. Go to that URL, you get links. And this book is all about how to build applications that use reactive programming. Now, reactive programming is what we're going to talk about today. Reactive programming, the question then is, or the answer rather, is how do I build applications that handle more users? How do I scale to greater heights? And this is a new answer. Reactive programming is a new answer to a very old question. It's a question that we have to understand now more than ever as we start to build microservices, as we start to work with Internet of Things, as we start to work with sensor networks, and we start to work with NoSQL in big data. As we move to this world, we start to see that the approach that we have taken for dealing with more users for larger amounts of data starts to become inefficient with respect to input and output on the JVM. And the reason it's become inefficient is because traditionally that approach has been limited to the number of threads that we have on the given JVM. So you have a JVM, and you're having more users in the system. How do you handle that? How do you handle more users traditionally? You add more threads, right? And the reason this is a problem is because the JVM cannot create infinite numbers of threads. This is very difficult for the JVM to do, and there's a couple reasons for this. First of all, the JVM limits the number of threads because it limits, because it creates memory associated with each thread. Each thread has about 1 megabyte of context, of bookkeeping that it has to keep in order to manage it. So if you have 1,000 threads on your JVM for simple math, then you've got an extra gig of RAM. You haven't even done anything, and you've already lost an extra gig of RAM, right? This is a problem. Another thing is that it's very hard to schedule work to move from user space down to the kernel and then back again, 1,000 times per second, for example. So while we could create 1,000 threads on the JVM, it would be very inefficient. It wouldn't be as fast as we want. And remember, the JVM is just doing scheduling. It's using the operating system, and the operating system is doing scheduling. But is there such a thing as 1,000 truly concurrent things on your computer? Not unless you have 1,000 cores, right? Beyond the number of cores, it's just an illusion. It's an abstraction. It doesn't actually exist. So the question is, can we schedule 1,000 things? And of course, the answer is no, unless you have 1,000 cores. If you have 1,000 cores, by the way, then that's almost enough to run Slack. So that's a big deal. Now, if we understand the problem, there's a couple of answers to this. How do we handle more users? For now, traditionally, up until this point, one good answer is just add more nodes. Add more servers to the load balancer ensemble. As you add more servers to the ensemble, to the cluster, you can handle more requests. And this allows you to write code without changing much, and it still kind of works. You just have to pay your cloud provider for more instances. And that works okay, but it's very inefficient. You're just doing the least efficient thing, but because you've built your application using microservices and 12-factor apps and whatever, you've reduced the cost of scaling out horizontally. But can we do better? Can we be more efficient? One way we can be more efficient is if we take advantage of asynchronous I/O. So what's happening is when a request comes in and we get the bytes from the client on the HTTP web server or something else like this, what we are doing is we're sitting there waiting for the bytes. The bytes come in and we're sitting there, oh, where are those bytes? Come on, come on. And we're sitting on that thread. It's not able to do anything else. We're waiting for those bytes to arrive. This is a problem. It means that we have these bytes, but they're not here yet, right? Because the network is not always super fast, and because services fail, and because of whatever reasons, right? Just the speed of the client might be an issue. If the bytes fail, if the bytes don't come, that thread is stuck. It's stuck waiting for this, and nobody else can use that thread. This is problematic because it means that we can't use it for anything else. So the question is, can we get off of the thread? Can we do something so that we're not sitting there on the thread for no reason. Asynchronous I/O gives us a way to do this. Asynchronous I/O is very simple. You say, I want these bytes, please, and then you exit, you move on. And later on, asynchronously, you get a callback, an interrupt saying, here are the bytes. Do with it what you want, right? So this is more complicated. The code is more complicated because you have to do interrupt-driven programming. You're waiting for data, and as it arrives, you process it. The benefit of this, of course, is that as soon as you ask for the bytes, you can get off the thread, and the scheduler can give that thread to other work. So as a request comes into the web server, for example, you can ask for the bytes, you can start processing it, and then move the work off the thread. And you're constantly moving work off the thread. This means you can handle thousands and thousands of concurrent requests because you're not sitting there waiting for the sequence of data to go back and forth. This gives us a lot of opportunities. The only problem is we need some way to describe these asynchronous, latent, unbounded streams of data. And so this is what reactive programming is all about, is how to write code, how to write business logic that maps naturally to this world of asynchronous I/O. We have the reactive streams specification. The reactive streams specification introduces 4 very simple types that allow you to describe asynchronous, unbounded, latent data. Is that enough, though? I mean, is it enough to solve such a general problem with just 4 simple types? I would say that it's not yet enough. I would say that these things need to be supported at higher levels for them to be useful. Imagine, for an instant, just let's have a hypothetical, an imaginary discussion here. What if the tools, the technologies that we have become familiar with, what if these different technologies that we have become familiar with, like Hibernate, what if, hypothetically, Hibernate didn't like Java util collection, and it didn't like Java util set and Java util list? What would that mean for us? What if it didn't just not like Java util set and Java util list, right? Because we all know Java util lists. We all know how to work with that. Imagine that for whatever reason, for some hypothetical reason, imagine that for whatever reason, Hibernate really hated Java util list and Java util set. It didn't just throw an exception. It actually rendered an ASCII art middle finger. And then kernel panicked the machine. Would you continue to use Java util set and Java util list if you knew that you could expect that kind of abuse? Of course not, right? You're not gonna give up Hibernate. Hibernate solves a particular problem very well. It's the best there is for that. But you want to get software into production. You want to ship valuable software. So you're not going to give up the tools that support that. You are, however, going to use something else. You're going to use whatever is recommended and supported. And so if that's not a Java util set, then you'll use whatever is recommended. The same is true here for reactive programming. We have these reactive types, the reactive stream specification, but they're not very good for us unless the things that build on top of that support these reactive stream types. So for us on the Spring team, the first major step in that journey came in September of 2017. We released Spring Framework 5, and we released Spring Data K, and Spring Security 5, and Spring Boot 2.0, and Spring Cloud Finchley. These releases all support these reactive types. So that, my friend, is what we're going to cover today. That's what we're going to look at today. In our limited time together, we're going to build a new application here at my second favorite place on the internet. This is my second favorite place after production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. Now, a bit about that, I noticed that you have something particularly dangerous here. You have something called rakia. And you should tell people about that at the airport. You should warn them, right? You have to be careful when you drink that rakia. Otherwise, you will end up the next day in a prison with blood on your shoes and PHP code on your laptop, not knowing what happened. You have to be careful. Let's see, is this on? Oh well, no power, who cares? So, let's build a new application. We're going to build an application at start.spring.io. We're going to build a service called the reservation-service, okay, like this. And I'm going to bring in some supported libraries. Reactive, let's see, we want Reactive Web, we want Reactive MongoDB, we want Lombok to make Java just a little bit less tedious. We want OurSocket. I'm going to use the 2.0 snapshot support. We'll bring in OurSocket if we have enough time. And I think that's it. I think that's enough for now. Maybe DevTools. Very good. So I'm going to go ahead and hit generate, and that'll give us a new project that I can open up in my IDE. And I'm going to use IntelliJ. It doesn't really matter what you use as long as you have an IDE. I'm going to use IntelliJ because it supports what I need. But anything that supports Java 8 and Gradle or Maven will work just fine. I'm using Maven by default. So NetBeans, Eclipse, Spring Tool Suite, IntelliJ Community, or IntelliJ Ultimate. All of these are good choices. Now, I've got a brand new project. I'm going to open this up. And we're going to build an application that maps data to the database. Okay, so reservation service application. Let me make that font. Oh, you can see that in the back, yeah? Yeah, okay, good. So we have an application. We're going to build an application that saves data to MongoDB. I've got MongoDB running on my local machine, and I want to create an object to map individual records in my code to a document in a collection. So a collection is like a table. A document is a single row. So we're going to say private string ID, private string name, and this will be a MongoDB document, and it's going to be all args constructor, no args constructor. What I want actually is I want getters and setters, right? I want the hash code and toString and equals. So I could do this. I could say give me getters and setters like that, and I could say give me toString, and I could say equals and hash code, and oh God, look at all that, right? And constructor and another constructor. Oh, why, right? I could do all that, sure. Look at that modern Java. Look at all that garbage. So just throw that away. Instead, I use Lombok. Lombok is a compile time annotation processor that will synthesize. It'll create for me the getters, the setters, the toString, the equals, etc. And what I want to do is I want to persist and manage the life cycle of data in the database. So I'm going to use a repository. A repository is a design pattern that's designed to separate the business logic from the boring reading and writing and updating of data. Now, this repository is just an interface. I don't need to provide an implementation. Spring Data will do this for me. This repository supports several different methods here, though. Save, save all, find by ID, check if it exists, count, delete, etc. And you can see that most of these methods are very familiar. Some things are very different, though. First of all, we have a publisher. A publisher comes from the Reactive Streams specification. A publisher is a thing that publishes data of type T. So you'll have a byte or a string or a customer object or an order object or a line item, whatever you want, you have a publisher of that thing, right? And who listens? Who receives the data? Well, the subscriber. The subscriber is given the new data whenever a data entry arrives. It's given the data in the onNext method. When there are any errors, those are given in the onError method. Now, notice that I said error, right? And notice that the method name is called onError. You see, contrary to the Java language designers, functional programming and reactive programming they treat errors as being non-exceptional. And when you build distributed systems, when you build reactive systems, errors will happen. They shouldn't require a separate control flow mechanism. Instead, they are treated as just another kind of data, just like a T, right? So you have an error or an item, but either way, you deal with the same way with the same kind of operators. When processing completes without any special exceptions, then we say it has completed, and this gets called back. Now, I mentioned those 3 methods, but there's actually a 4th one here that I didn't cover because this deserves more attention. OnSubscribe is called when the subscriber subscribes to the publisher, and it is where you are given a subscription. The subscription is the link between the producer and the consumer. It is a session. It represents the unique connection between one subscriber and the publisher. And the reason you have this is because you need to be able to ask the producer to slow down, right? Think about basic network programming that we would have done 60 years ago. As soon as or 70 or 100 years ago, as soon as you have 2 computers connected to a network of any kind, there's a risk that one will go faster or slower than the other. And so it is important that you have some way to negotiate the speed of exchange. That's called flow control. It's a very basic concept, and it's still there. It's still done for us at the TCP/UDP layer. When you deal with distributed systems, however, it's important to elevate that concept to a first-level, top-level construct. That's what we're doing here. We're saying, I want to request 10 more records or 1,000 more records. What does that mean? It means that the publisher will give me no more than 10 records at a time or 1,000 records at a time. It might take 10 years, but I will only get 10 records. And then when I want more, I request more, okay? This flow control is an old idea, but in the world of reactive programming, the marketing sometimes takes over the actual technical details. So in the world of reactive programming, we call flow control back pressure. So if you see back pressure, that's just a fancy way of saying something that has been around for half of a century, okay? If you want to cancel the production of data, you call cancel. All right, so do you understand all that so far? That's publisher, subscriber, and subscription. There are 4 types in the Reactive Stream specification, and I've only covered 3. The 4th one is called a processor. This one is super easy, right? A processor is a bridge. It's a producer and a consumer. And that's it. That's the whole thing. If you understand those 4 types, congratulations. You're certified reactive. Go to Silicon Valley. Get venture capital money. Start a company that will have large, loud parties for 6 months and then burn out. It's going to be fine, right? You're already way ahead of most people in Silicon Valley. That said, you notice that those publishers are fairly boring, simple things. They don't have operators that support filtering and mapping and transforming and streaming over these sequences of data. That's why it's important to have specializations, special subtypes that support the kind of operations that you might expect from, for example, the Java 8 Streams API. One of those specializations is called a mono. A mono is a publisher. You can see it implements publisher, and it's provided by Reactor, Pivotal's Reactor project. But it supports complex operations like map and flat map and filter. A mono is a publisher that produces only at most 1 record, so 0 or 1. Think of it kind of like a completable future, but with back pressure and also push semantics, right? The data is being pushed to you instead of you having to pull the data from the stream. On the other hand, we also have a flux. A flux is a publisher as well. You look at the publisher, and it's a publisher of type T that supports 0 to unlimited data. It could be 5 records, it could be 1 trillion records, or it could keep going forever and ever and ever. That's the whole point. It's still just a publisher. It's kind of like a Java 8 stream, but with back pressure. Now, these publishers, these types, are so useful, so obviously useful, and they fill a very big hole in the JDK. There's a big hole in the JDK because these weren't supported for the longest time. So if I go back to my build here and use Java 11 instead of this ancient, creakingly old version, if I use Java 11 like this, bring that in, do Maven re-import, now you can see that these types, publisher, for example, are now in Java 9 or later. So if I go here, JDK 12, Java util, concurrent flow. And when I go to that type, you can see, look, I've got flow.processor, flow.subscription, flow.subscriber, flow.publisher, the same exact types in the JDK itself, okay? So you will see that most of the libraries that support these reactive types understand the old reactive stream types and the new JDK 9 types, both. because they are the same thing and they serve the same use cases. Now, we have this repository. Let's write some data to the database, okay? So sample data initializer, all right? And we're going to create a bean that listens for an event and write some data to the database. So it's just going to be a Spring bean that's going to be started when the application starts up, and I'm going to inject my reservation repository and use that to write data to the database, okay? So I'm going to create a hard-coded list of names. My name is Josh. It is so nice to meet you. I'm going to list some other names here, Madura. I'm going to look Dr. Sire. I've got Cornelia. I've got Violette. Whoops, actually, we want Stefan. We want Nevin. We want, who else do we want? We want Olga. We want Violetta. There we go. Okay, so that's 8 names, right? And if I assign that to a variable, I can see I have a publisher of names. Now, what I want to do is I want to turn each name into a new reservation. So I'll pass in null, and I get a publisher there of reservation objects, okay? Now, I want to save each one of those into the database. But what happens is if I say reservation, and then I say give me the save method, and I pass in that reservation, what does save return? Save returns a publisher of type reservation. And what does map do? Well, map creates a publisher of the return value from here. So what I get is a publisher of publisher, like this, right? I don't want a publisher of publisher. I want just a publisher. So I get rid of that, and I say give me a flux of just T, and here I can say flat map, okay? Flat map will unpack the intermediate type. Now, what happens if I run this code right now? Nothing, right? Nothing will happen. This code is called a cold. It's a cold stream. It's not hot. It's just like the Java 8 Stream API. You have to activate it. You have to execute it. So what you do is you say saved.subscribe, okay? And that actually forces the cold stream, the pipeline, to execute. But nothing happens until you do that. And so you can provide a subscriber, or you can use some of the other overloaded methods from Reactor. One of them takes a consumer, so I can pass in the reservation entity there and just log that out like this. Now, I can rewrite this as a lambda, of course, good stuff. I can turn that into a method reference, very good. And let's run that and see what we get. All right, nice. There we go. Now, the problem is that if I run this program multiple times, I'll have duplicate data. So what I really want to do is, actually, I want to delete everything first. So I say this dot reservation repository dot delete all. But delete all returns a publisher, a asynchronous stream. So I have to subscribe. The problem is that this is asynchronous. There's no guarantee that this will finish before the next line, right? Before here. And so the result could be that I'm deleting and writing data to the database at the same time, right? What I want to do is delete everything and then write everything, one before the other. Okay, well, how do I solve that? How do I force this to execute before that? I could say block, right? Ugh. Code like that makes me want to take a shower. No, that's a terrible idea. Here I have this non-blocking reactive API, and I'm using block. Instead, you use .thenMany. Okay? And then many takes a publisher. So I'm going to take this publisher of type reservation, and I'm going to clean it up a little bit. I'll get rid of the intermediate variables here. Get rid of that, all right? And there's my new publisher. It's a pipeline that has multiple stages. And in fact, we're using Java 11, so that's even better, right? So what I'm going to say is delete everything, then do that, then I want to find the data, and then I want to log it out. So system out print line. All right? Let's restart that. Coffee. Okay. So, did it work? Did it work? Did it work? Look at that. There we are. We happy few. Of course it worked. It was a demo. What were you expecting? That was always going to work. There we are on the console. It worked. That's not what I wanted to talk to you about. That's not why we're here. What I wanted to focus on was this. This is the ASCII artwork. This artwork took a long time to get right, but we on the Spring team have many people who are doctors, PhDs, people who worked in nuclear physics. Very smart people. So it makes me very happy to imagine that someday, somewhere, somehow, there's a GitHub issue, and it said, we need good ASCII artwork, and I think you can agree they did a great job. And so it's for this reason that I want to take a very small break, a very small digression, to talk about what I consider to be a very serious and glaring bug in IntelliJ JetBrains. Do you see this checkbox? This one right here? This one. Do you see that checkbox? That one right here? This one? Do you see it? Do you see it? Do you see it? That one. Do you see it? Do you see it? That one? This one right here? This one? Do you see it? This one right here? That one? This one. That checkbox, once clicked, suppresses the output of the ASCII artwork. It hides the banner. What the hell? So I did what all people would do in the same situation. I did what anybody would do. I'm not a hero, okay? You don't have to thank me. I did what everybody would do. I went on the internet and I cried. And I sent a message of pain out into the internet. And my friend Jan Sabron, he's a software developer by passion at JetBrains. He responded. This is Jan, by the way, right here. That's him. That's him. Boop. Anyway, he sent me this message of hope, which I will share with you here today. He's a friend of mine, and so I want to believe him. He says, Josh, don't worry. In the next release, it'll be fixed. Don't worry, man. Just relax, he says. It's going to be okay, Josh. And I want to believe him. We've been friends for a long time, but you know what? I'm starting to think that maybe, just maybe, maybe he's not being sincere. I don't know. Anyway, moving on. We have amazing ASCII artwork, and we have data in the database. Now what? Well, the natural next thing is we should build a HTTP endpoint. So I'm going to build a REST controller, a reservation REST controller, right? Like so. REST controller. And I'm going to inject my reservation repository like so. And we'll start this up, add a constructor. And I'm going to call the endpoint here, reservations. And we're going to return a publisher of the reservations from the database. Okay, like so. And restart. Localhost reservations. There we are. Okay? So there's the reservations endpoint that we've just created. That took a lot of work, but it works, right? Now this is fairly familiar if you've ever used Spring MVC, at REST controller, at get mapping. These are the same annotations from Spring MVC. But even though it looks like it's Spring MVC, this is not Spring MVC. There is no servlet API anywhere here. We're using a brand new web runtime built on top of Netty. This is built from the ground up to support asynchronous and reactive I/O. The benefit of that is that we can do some very simple things now that used to be more difficult. For example, even though this is just a very simple 8-record result set, we can also handle asynchronous unbounded streams of data as well. Let's say that I wanted to do server-sent events, right? Server-sent events are a way of sending back a value or a stream of values to the client from the server. The client looks at the content type and it says, oh, I'm not going to disconnect. I'll just keep reading. I'll keep the socket open and keep reading the data. So here, I'm going to create a publisher that produces new data every second. I'll say stream.generate, and I'll use a supplier, and I'll return hello world at, and I'll provide an instant as a check of when it got sent, okay? So I'm going to use a lambda there. And then I'll say delay elements, duration of seconds, all right? So I'm going to send a stream of values, and I'll stagger the results. I'll produce a new result only every second. So let's restart that. And what did we call it? SSE, right? Is that not what I called it? No, here we go. There we go. So there's my stream of data, okay? So you can see that's there as well. And it's going to produce new data forever. You can use this from the browser as well, right? You can do this in JavaScript, for example. It's a great way of sending status updates or stock tickers or notifications or presence notifications, that kind of thing, okay? Now, I like this. I like the fact that it's so easy to send long-lived streams of data. Let's see now. I've been using this Spring MVC style, and this style is very familiar, but it's good if you have related endpoints in the same class and you want to share a common dependency, for example. You can do that using this style. But we have Java 8, we have lambdas, and so there's a new style as well now called the functional reactive style. So here, I just define a bean of type router function, rather, and I can say .get /reservations, and I'm going to return a new handler function. And my job in there is to return a response. So I'm going to inject a pointer to the reservation repository, and I'll return rr.findAll reservation.class. Now, this is going to do the same thing as the other one. I'm going to clean it up using a static import there. And there's my new reservations endpoint, right? I can get rid of all of that, okay? Much better. Let's see what that looks like. By the way, one thing that makes my life better is lazy. Always do lazy. All right. So now, okay, so there's our application. Here we go. 404 not found. What did I call it? Oh, reservations. Right, I got rid of the other one. Reservations. Okay, so there's our endpoint. So now we've got the same thing as before, but it's much simpler to read. I like that style. Which one should you use? Well, remember, this is a dynamic builder object, so you can dynamically register things. I think that's kind of interesting. Okay, so I showed you service and events. I like service and events, but there's other ways of doing communication between producer and consumer. One very common approach is to use WebSockets, right? WebSockets are actually bidirectional, but it's a separate protocol. It's not HTTP now. And so it's a little bit different, but it's still easy because as long as you understand publishers, then you understand what you need to do. There's a simple way of thinking about it. When you're not sure, use a publisher. Okay, well, fine. It's fine. Anyway, WebSocket configuration, and this is going to be a thing that produces publishers, and I'm going to create a bean that is of type WebSocket handler adapter, like that. Return new WebSocket handler adapter, good. I'm going to create another bean of type WebSocket handler, and the WebSocket handler is where our business logic lives, and we're going to come back to that in a bit. And then the final thing we need is a simple URL handler mapping. New simple URL handler mapping, and then we're going to return the result. So I'll say I want it to be ordered 10, and I'll say URL map equals map.of, and we'll say WS greetings, okay? And in order to provide that response, what I'm doing is I'm mapping this component of type WebSocket handler to this URL, okay? So there's that, good stuff. Now, I'm going to do the same thing as I did for my service and event example. And so actually, what I should have done is I should have, I didn't extract it out, but I can do the same thing here. Class, greetings, timed greetings producer, flux of string greet. I should have saved it and reused it, but I didn't. That's my fault. Stream.generate new supplier, okay? So hello world at instant.now. And all I'm going to do is I'm going to produce a new stream every 1 second, okay? So there's this. Replace that with a lambda, and this will be a regular Spring bean. And I'm going to use that in my WebSocket code. So up in my WebSocket logic here, I'm going to inject that timed greetings producer, TGP, and I'll say I want to take the stream of data, tgp.greet, store that as a variable, var greetings stream, and I want to take each one of those and then map it into a text message. So string WebSocket session.text message, passing in the string. That can be a method reference. That's nice. And what I want to do is I want to send that out. So I'll say WebSocket session.send greetings stream. Okay? Now that you understand what's happening, I can just actually inline it like this, get rid of that, and I can use a lambda like that. And there you go. There's my WebSocket handler. Okay? Now restart. Oh, I've restarted the application, but now I need to do something terrible, something that I'm not proud of, something that you should never, ever do, ever. Not even when you are all by yourself at home and no one is looking. I'm going to write JavaScript. So here we go. Source main resources, directory, static. Same mistake. Amazing. And I'm going to create a new file here called ws.html. And body and script. And it'll be var, window.add event listener, load, function, e. And then in there, I want to create a WebSocket pointer, ws localhost 8080/ws greetings. Okay? I'm going to say ws add event listener message function message. And there, I'm just going to log out the results. Whenever a new message arrives, I'll print it out. So message.data. Okay? So all I'm doing is I'm creating a listener that listens for when the application starts up, and I'm going to log it out in the console. I think that's all I need, but let's see. Restart. Okay. And then I called this ws.html, I think. And if you look at the output there on the console, you can see I'm printing out the new results every 1 second. Okay? Very, very simple. Very, very simple. Now, the reason I'm so interested, and the reason I like to show you this stuff with the duration, is because I want you to understand that there is a publisher, there's a scheduler behind the scenes here, right? There's a thing behind the scenes that's moving work from one thread to another, and we don't usually have to worry about it, right? Because as long as we're using reactive, non-blocking code, then you're fine. You don't have to worry about it. You're not going to block the thread, right? And so here, in my pipeline, I created all this stuff, and when I delete everything, that's asynchronous. It could take multiple threads. It could happen in one thread. And then when I write the data to the database, that's asynchronous as well. It can happen in multiple threads or a single thread. And then when I return all the data, that's potentially asynchronous as well. So I've got 3 different things that are asynchronous and concurrent, potentially, that are happening one before the other. I don't have to worry about that, though, because I'm using these operators, then many, right? And the operators guarantee that I get deterministic results. I'm not worried about how this is being done. There's no countdown latches. There's no cyclic barriers. There's no phasers. There's no runnables, no executor services, none of that, right? I don't need to as long as I use non-blocking I/O. If you want to manage the scheduler, if you want to actually create your own scheduler or something, you can do that. If you want to override it, for example, you can say, okay, well, I want this code, the code that comes before this, I want that to run on this scheduler, which is backed by this executor thread pool, right? You have control if you need it, but you shouldn't need it. That's a smell, right? It's not a good thing if you have to control that. That means you've probably got some code that blocks. And one thing that people ask about is, well, I want to talk to a SQL data store. All right? I showed you MongoDB. I showed you Cassandra. I could show you Cassandra. I could show you Redis and Couchbase. These all have reactive drivers. They have natively asynchronous drivers. And we are building a Spring Data abstraction on top of those natively asynchronous database drivers. But a common question people ask is, can I use JDBC? JDBC is, I think, a very nice piece of technology, but it's blocking. It's synchronous. And so it's not a great fit. But that is separate and apart from, can I use SQL? Okay? Many of the different SQL database vendors have asynchronous drivers. They're just not JDBC drivers. And so we have a project in the Spring ecosystem called R2DBC. R2DBC is the Reactive Relational Database Connectivity Abstraction. This is an SPI that provides a generic interface and a number of different implementations, including Postgres, H2, and Microsoft SQL Server. Now, these are the ones that we are providing, but there's a third-party project as well called JawSync, and they have a MySQL driver as well. So you could Google that, and you'll find that they also have an R2DBC implementation for MySQL. Now, this is not GA yet. It's not finished, released code yet, but it still works, and I want to show it to you. But I want you to remember, for now, that it's not yet intended for production, okay? I want you to regard this, to look at this project with the same level of terror, okay, that you regard PHP, okay? Production should be over here, PHP over there. Never the two shall meet, right? Never. Same thing for this, for now, okay? So we're gonna build an application that uses R2DBC, but because there is no Spring Boot auto configuration out of the box, I have to write a little bit of code. First things first, I'm gonna add the dependencies. Desktop, MISC, deps, R2DBC. I'm gonna add this to my build, like so. Paste that in there. That's the MySQL dependencies, but I'm not gonna use that. I'm gonna be using R2DBC and Spring Data R2DBC and the Postgres driver, okay? And now I need to get rid of MongoDB, so I'll comment that out as well. And really, in the future, you know, I hope that this is all that I have to do is to delete the document annotation and change this from a string, a UUID string, into a monotonically incrementing integer, right? So you see up until now, db.reservation.find, I've been using this, right? You can see there's the names that I just put in there, right? But now we're using Postgres. So if I go to Postgres and I look here, pSQL, U orders, D, D reservation, there's the database table, ID and name. So I'm going to use that instead. I'm going to do delete from reservation. Okay, there's nothing there. And I'm going to now, I want to be able to just run this program, but for now, I still need to do a little bit of configuration because there is no auto configuration yet. I need to create the connection factory by myself, manually, okay? So R2DBC config extends abstract R2DBC configuration. And finally, I need to say @enable R2DBC repositories. And normally, you would keep the following configuration outside of your Java code. It would be in a separate config file, but, you know, hashtag YOLO. So, orders, password will be orders. Shh. Don't tell anybody. Username will be orders. Host will be localhost. Database name is orders. And I guess that's the name. Orders, whatever, fine. Okay? And that should be enough. That should be the entire thing I need to do. And remember, here, it's UUIDs, right? You can see that. Now I'm going to use Postgres. I'm going to use, an integer, auto-incrementing primary key. There's the numbers, okay? And now, select all from reservation. There we go, all right? So now we've done reactive SQL-based data access as well, very easily. Now, how much time do we have? Oh, plenty of time. Let me show you one more thing. One more thing. So I like HTTP. I think HTTP's got a future. Don't quote me on that, though, okay? But I know it's controversial, but I believe that HTTP one day is going to be big, right? Is that negative, or do I still have 8 minutes, roughly? I don't care, whatever. Anyway, it looks like it's red. It means it's in the last 10 minutes, I assume. Anyway, I believe that HTTP is going to be big one day. You just watch. But it's a great document retrieval protocol, but it's not a particularly great application protocol. And what I mean by that is that raw TCP UDP gives us a lot more flexibility than HTTP. But it's very low level, so most of us do our work using HTTP. HTTP is great for doing request response, give me a document when I ask for it kind of interactions. But there's a lot of things that applications can do if they know how to use the network. And so a lot of different organizations are looking for ways to go faster. They want to be able to support other kinds of message exchange patterns. For example, fire and forget. I want to send a message, and then I want to have the optimization where I don't have to produce a response or wait for a response. Or I want to send a request and get a stream of values back. Or I want to send a request and have a stream of values that go in and then a stream of values that go back. Also, I want information in that stream to be to know how the service is doing. Is it healthy? Is it happy? Right? In Spring Boot, we have the Actuator. Actuator are a set of HTTP endpoints that give you the health and uptime and things like that, metrics, etc. But this is only by sort of agreement between us, the Spring Boot framework developers, and you and your production systems and your consumers, your producers and consumers, and your middleware. That's the only reason that works. But there's no built-in thing in HTTP to communicate that kind of data. So we need a protocol to support that as well. Also, we need something that supports binary data, right? Remember, HTTP is textual. You send a request, you get back a text response, and if you want to convey binary data, how do you do it? You base64 encode it into text, right? That's just silly. So there's a lot of these sort of things that are just really, really basic problems for high-speed services. A lot of different organizations have tried to solve this. Google created gRPC, right? And gRPC requires you to code generate your classes based on a service definition. There's even Salesforce, which has a compiler plugin for the gRPC compiler that creates reactor-based services, which is kind of interesting, right? Reactor is what we've been using so far. Another approach to this is something called OurSocket. OurSocket, okay? And OurSocket was originated by, guess who? Facebook. Facebook, as far as I understand it, they're a cat picture website that is designed to spam you mercilessly and endlessly until such time as you hate yourself and everybody else, right? I don't know what they do. I don't use it personally, but nonetheless, I understand that they're a pretty big website. People are using it, and they're going to be big one day. Now, they have pretty big scale, as I understand it. So they created a protocol called OurSocket. OurSocket is natively reactive. It has back pressure built into the wire protocol itself. It has a message frame for communicating uptime. It has all this and so much more, and it supports all those 4 different message exchange patterns that I just described. OurSocket is something that's being used in production by Facebook. And of course, a lot of the people that worked on OurSocket at Facebook came from Netflix. They worked on RxJava at Netflix. So it's very natural that when the people at Facebook wanted to create a Java client for OurSocket, and they needed a Java reactive library, of course, they chose Reactor. Right? They chose Pivotal Reactor. I don't know why. I like to assume it's because we're awesome. Either way, this is a nice fit for our application. And so Spring has just recently now integrated OurSocket. It's going to be GA in Spring Framework 5.2 coming out later this year, and Spring Boot 2.2 coming out later this year. But we're using the snapshots, and it's already there. So what I'm going to do is I'm going to use the Spring Boot Starter OurSocket, which you saw me add earlier. I'm going to build a different service, this time using OurSocket. So it's a controller class. We're going to use an OurSocket greeting service, okay? And all I'm going to do is I'm going to create a single endpoint, and it's going to be greetings. And I'm going to return it's going to be greetings. It's going to return a publisher of strings, greet. Okay, and actually, I'm gonna expect a payload. I'm gonna expect a name. And so we're going to change this existing example, this existing endpoint that I had earlier. This will take a string name, okay? And I'm going to say hello name, like that. And what endpoint was using it? It was the WebSocket one, right? So we can do 2 variants, publisher of string greet. If it's got nothing, it'll just return this.greet world, okay? So the WebSocket one will work, but I'm going to inject this in the OurSocket endpoint, like so. Private final. Good. Add to the constructor. Clean it up. Good. And all I'm going to do is I'm going to say return this.greet, passing in the name. So there's my endpoint. That's it. That's the message mapping, right? That looks very similar to the WebSocket support in Spring as well. And we're going to return a reactive publisher. And we know that this publisher will continue to produce new data all the time. Now, I'm going to create a client to use that, okay? So I've got that service. Oh, I need a port also. I need to create a port. So I'll say OurSocket port equals, let's say, 7,000, okay? Restart that. Now, I'm going to go back here, start.spring.io, and create a OurSocket client. And here, we're going to use 2.0 snapshot, OurSocket, and reactive web. I'm going to create a REST API that calls our OurSocket endpoint for us. We've got 2 minutes and a half. I think that's plenty of time, friends. It's a good thing I don't leave this to the last minute. OurSocket client, good. So here's the, there's the producer. And on the consumer side, same as before, we're going to have OurSocket auto-configured for us. We need to do some OurSocket configuration. I'm going to create a bean of type OurSocket. And I'm going to say at configuration, OurSocket factory.connect frame decoder, okay, 0 copy, data mime type is mime type utils, application JSON, and the transport will be TCP client transport, and we're going to connect to the server running on the port 7000. Get that and get that block, okay? And now I need to create a client-side object to make calls to OurSocket. So I'll create an OurSocket requester. This is a client. So return OurSocket requester.create this.OurSocket. And we're going to say mime type utils, JSON, and we're going to use the OurSocket strategies. Okay, this is automatically configured for us by the Spring Boot auto configuration. And there we go. Whoops, not value, just this one. There's our OurSocket client. Now we can create a simple REST controller that demonstrates using that. So I'm going to create here a controller, a REST controller, an HTTP controller, class greetings client REST controller. I'm just going to have one endpoint that produces service and events, text event stream, value, greetings name. All right. And produces a publisher of type, what do we want? We want to say, actually on this side, we need to, let's show some content conversion. So greetings, request, private string name. Okay, that's a POJO. So we're going to demonstrate that Spring provides message conversion for you. So class greetings response, private string message or greeting at data at all_args constructor at no_args constructor. Okay, so that's our entity. That's our POJO. And copy and paste. Don't ever do that. Lombok. Good. Alrighty. Whoops. No, definitely not. On stage? Are you crazy? So okay, we've got to change our endpoint here. I'm going to say return a publisher of greeting response. Okay, and I'm going to take a greeting request as the input. So I'm going to say greet name.getName, and I'm going to map each string into a new greeting response. So pass that in. Okay, so we're just adapting it to use these POJOs now. Okay, everything else is the same. We can restart the producer. On the consumer side, we're going to take the greeting response, greet stream, and we're going to expect a payload, path variable, string name. We're going to say return this dot sender. We're going to inject our OurSocket sender here, our OurSocket requester, and we'll say this dot requester dot route. And the endpoint is called greetings, right? The OurSocket message endpoint is called greetings. The data that we're going to send in is a new greeting request. And it's going to have the name as the payload. And we're going to retrieve a publisher of type greeting response from the results. I'm going to send that back as a service and event stream, okay? And we are just about out of time. So here's one for all the marbles. This is running, oh, wrong port. Server.port equals 8081. And we called this endpoint, what did we call it? Greetings name, 81, greetings world. All right. So now we're doing binary communication from one node to another, super fast, supports natively reactive streams across the wire. We don't have to compress and we don't have to encode as text and then back again. We can do bidirectional communication. We can do service and events. We can interop with everything else that speaks WebSockets, or sorry, reactive streams. So WebSockets, HTTP, R2DBC. We can now do all sorts of very interesting scatter-gather kinds of composition of different microservices. You can call service A and service B and service C, join them together, etc. My friends, the future is reactive. I hope you can appreciate that after spending some time with me. I want to thank you so much for your time today. What is the right word? Halal. Havala. There we go. Thank you so much, my friends. I appreciate everything.